And no, Joe and I have not been around each other.
Cindy, are you feeling sick too? Did
I
yeah.
didn't think I was going to be able to have class last night.
Oh man. Yeah. Yeah. Sorry about my voice. So, uh, okay. Well, I'll mute myself so I can call. Okay. So today, welcome to day 25 of Math 133. Today we are going to be talking about the Chapter 10 review. Chapter 10 review starts on page 526. 526. So, um, okay. So, uh, today is Thursday, and 3 weeks from today is our final exam. Okay. The reason I point that out is because normally, if you turn something in late, well, I'll mark a couple points off, but you can still turn it in. Um, except if something is more than 3 weeks late. If it's more than 3 weeks late, I won't be able to grade it. Okay. Um, but starting today, that's going to shift. That's going to change because uh, I have to turn in final grades um, the Monday after final exam. So final exam is on the 11th. So the last chance to turn anything in this class is December 12th. Okay. So midnight on December 12th. If anything comes in after that, it's not going to get scored. Okay. Even though it might be less than 3 weeks late, anything after December 12th is not going to get graded. So just be aware of that. I know that I'm behind on my own grading. So I'm going to use Thanksgiving break to catch up on things. So if you are also behind in turning things in, now is the time to catch up and make sure that everything is turned in before the end of the class. Okay. All right. So today is the Chapter 10 review worksheet on page 526. All right. So I'll go through and give you a couple of hints before we go back through everything. So, Chapter 10, the exam notes packet for hypothesis testing, you'll find lots of information on page 262 and 263. Page 262 is if you're looking at a proportion, page 263 is if you're looking at a mean, right? So pages 262 and 263. Okay. All right. So let's start with number two. Pairs of p-values and significant levels alpha are given. For each of these, determine whether the observed p-value leads to rejection of the null hypothesis at the given value of a. So, uh, so for step 5, we compare our p-value and our alpha, and if p-value is less than alpha, then we reject the null hypothesis. Okay. So if our p-value is 0.2 and our alpha is 0.5, do we reject or not? So, yeah, because of my voice, I'm going to need you guys to speak up tonight. So, yes or no? What do you think? For study A.
Yes.
Yeah, you got it. Okay. 0.2 is less than alpha. Yep. Is less than 0.5. What about this one? 0.004 and 0.004.
No.
So this one is a no. Now, I will point out that in this class, we've played very fast and loose with less than or less than or equal. Okay. So, like, For example, here where we say like n times p times q has to be bigger than 10. Well, it's actually bigger than or equal to, but we almost never see it equal to 10. For this, we reject the null hypothesis if the p-value is less than alpha. What if it's, but it doesn't say less than or equal. So you are correct. It is null. It is no. Okay. It is no. But the chances that your p-value are exactly equal to alpha are almost zero. It's never going to happen. Okay. So we usually want to reject the null hypothesis. We usually are, when we're doing these tests, we want to see some, improvement, some results. So usually rejecting a null hypothesis, I mean, that's what you're hoping for. So if it is actually equal, I would be okay with rejecting if it was legitimately equal. Okay. But it is no in this case. Okay. We'll come back to the other ones, but okay. So, all right. Which study had the lowest chance of a type 1 error?
B. It has the lowest alpha.
So we're looking for the one with the smallest alpha. So the smallest alpha in this case would be B, right? 0.004. Mhm. Now, for this one, we're looking at alpha. For this one, the lowest chance of a type 2 error is beta. And we don't have beta. Okay, we aren't going to measure beta. Beta is based on your sample size, but it's also based on your alpha. We don't want to make an error. So we want to make our alpha as small as possible. But if you make your alpha too small, that makes your beta larger. Okay. If all of these have the same sample size, all these studies, then we can just look at the alpha and say, okay, which one has the largest alpha? So the largest alpha here would be A. Okay. So, okay, well, you don't want to make a type 2 error, then make your alpha as large as possible, but then that makes it so that you are more likely to make a type 1 error. Okay. So what do? How do you avoid errors? Well, um, when you are setting these alphas and beta, or when you're setting your alpha, um, to what you're going to test against, you have to have a conversation about like what do the type 1 and type 2 arrows mean, and which of them are going to be a problem. Okay. Um, so when we were talking about measuring the number of purple Skittles in our bowl, um, did it matter if we made a type 1 or type 2 error? No, probably not. Okay. If we're talking about how many M&Ms, it doesn't matter if all the M&Ms are blue. Okay. They'll taste the same. So for M&Ms anyway, they do. So yeah. On the other hand, if we're looking at like safety of like you know, an airbag in a car and I'm testing that, it does matter if I make errors, because if my results are that like I reject the null hypothesis when the null hypothesis is actually true, it could mean people get in crashes and their airbags still go off. It could be dangerous. Okay. So um sometimes a type 1 error is worse. Sometimes a type 2 error is worse. Okay. I mean, sometimes they both suck, but we'll see. We'll look at those a little more today. Um, okay. So which study had the most statistically significant results? So this is whichever one has the smallest p-value. Which one had the smallest p-value for this? For these
C.
questions? So A is 0.004. C is 0.003. So they're both very small. C is smaller. So, okay. Um, okay. So then which studies had statistically significant results. So to be statistically significant, you have to reject the null hypothesis. So your p-value is less than alpha. So A was a yes, and C, and that's because the p-value is less than alpha. Okay. All right. We do not know if any of these studies had results that were practically significant. Explain why not. So, what are we studying for number two? We have no idea. We have no context. Okay. We don't know if we are talking about measuring M&Ms where like if we find that, you know, someone messed up and now all the M&Ms are blue, that's not going to change anything. That's not going to mess anything up. Or if we're looking at like, you know, a new medicine that we're testing, and if we make an error, then we could be putting out a medicine that is not effective. It's or even dangerous. Okay, we have no idea what we're measuring, so that's why these are all statistically significant, but that doesn't mean they're practically significant. Okay, all right. Let's look at. We're going to move on to the next page. Page 527. A manufacturer is designing a new jet airplane part that is critical for keeping the engine going and the plane in the air. Testing the new part for strength and comparing to the old traditional part that they've been using. If the new part is stronger than the old one, then they will install it in their new jet engines. Okay. So, null hypothesis, the new part is not stronger. The alternative hypothesis would be the new part is stronger. Okay. So the actual situation, we're going to write basically exactly the same thing. New part is not stronger. The new part is stronger. Now, we don't know the actual situation. Okay. Why not? Well, we can't measure the entire population. So as we're producing these parts, we can't test every single part because how are you going to test it for strength? What you'll do is you'll take that part and you'll apply pressure and you keep applying it more and more pressure until it breaks. And then you measure at what weight it broke. Well, you can't measure that on every part because when you measure it, you break it. So if you test every single new part, you break all of them and now you can't use them. Okay. So what you have to do is you have to do a sample, a random sample. So maybe you'll test like 1,000 of them and you'll break those ones, but the rest of them, and this is what companies actually do, is they'll pull things off the line and test those. Okay. So you can't really know what the actual situation is. That's why you do a random sample. But based on your sample, we're going to make a decision. And that decision is, do we install the null, or sorry, do we install the part in our new planes or not? Okay. So if you do not reject the null hypothesis, that means you believe it's to be true. You believe the new part is not stronger. So that means you will not install the part. Okay. If you reject the null hypothesis, that means you believe that this is wrong and actually the alternative hypothesis is correct. And so you will install. Okay. All right. We'll fill in the rest in a little bit. Okay. Let's go to page 528. Verify the requirements to conduct a hypothesis test are met. So is it random? Is it independent? And normal. Okay. All right. Now, when you're testing, when you're looking at this, conventional wisdom says the average movie length is 2 hours. So movie length is not a proportion. So uh, we're testing whether the average movie length is 2 hours. So to verify the hypothesis testing. Okay, so we're not going to be doing it for proportions. We're going to be doing it for means. Okay, so we're going to use page 263. Mr. Claim at a 1% significance level showing all steps, works, and graph. Use minutes, not hours. How many minutes are in 2 hours? How many minutes are in 2 hours, guys?
120.
120. All right. So there's 6 steps. So step 1, step 2, step 3, step 4, step 5, step 6. Okay. All right. We'll come back to that in a second. Page 529. An article of CNN stated less than a third of Americans own a gun. So this time we are looking at p hat, and so that's a proportion. So we'll use page 262. Okay. State the null and alternative hypotheses. So the null hypothesis is p equals something. Okay. Whenever you're doing the null hypothesis, it's always equals, and it'll be mu equals for a mean or p equals for a proportion, because mu and p are the symbols we use for measuring a population. Okay. And the alternative hypothesis will be p less than, greater than, not equal. Okay. So this is actually step 1 of our 6 steps that we do. Determine the null and alternative hypothesis. Okay. Verify the requirements to conduct a hypothesis test are met. So random, independent, normal. Okay. And then down here, we've already done step 1. So you can start at step 2 if you want. Step 2, 3, 4, 5, 6. Okay. Or if you want to fill step 1 in again, that's fine. You can do that. Okay. Okay. I'm going to stop my recording and we'll go back through and answer the rest of the questions.